So functional programming, in the sense of avoiding state, can be either data type oriented or object oriented. It also turns out that functional programming, in the sense of functions, can be object oriented. That is, we can use functions to represent objects even if our programming language doesn't provide specific support for objects. To start, let's suppose that all of our objects have just one operation on them, just an area operation, say. We can represent a shape then as a function that, when you call it, gives back an integer, that is, gives back the area of the shape. And if we use this encoding, we can define rectangle and squares as constructors that take some arguments and give you back a shape. That means what they give you back is a function that takes no arguments and returns an area. So a rectangle takes a width and a height and returns a function that multiplies those two numbers, while square takes just one number and gives you back a function that multiplies that number by itself. In either case, we have a shape. And then here is showing the creation of a rectangle R, and then calling the area method on R, which, since we just have one method, is calling the function R. Let's try this in Dr. Reckitt. So I've got that same code there. I've defined my rectangle object R. I can get its area. If I look just at R, it is just a function that takes no arguments and returns an integer. I can make a square by calling the square function. And I can get the squares argument, area, by calling it like a function. So we get the area 81. And if I want a circle, well, I don't have a circle constructor. I could just make a function directly that takes no arguments. And let's say that our radius is 2. So we're going to square the radius and then multiply it by roughly pi there as 3. So now C is just like a rectangle and square. It's a function. Its type is that it takes no arguments and returns an integer. And so we can get its area by calling C as a function. If I want to make multiple different circles, then instead of returning this immediate function here, I can put it inside of a function that creates a circle, given a side length, or a radius, I mean, and returns that same function. So now instead of 2, it'll be the radius. And now I can make a circle of size 3 instead of 2 and get its area, which will be 27. So this illustrates how functions can implement very simple objects, ones that have a single method on them.